Far beyond Earth, nearly 1 million miles from our planet, the James Webb Space Telescope drifts silently through darkness. Its massive golden mirrors remain permanently shielded from the heat of the sun by a structure as large as a tennis court. Suspended in deep space, Webb does something extraordinary. It looks backward in time. Every faint photon reaching its instruments has crossed unimaginable distances across the universe. Some began their journey billions of years ago, long before Earth existed, carrying ancient records from an era when the cosmos was still young. To observe these distant lights is not simply to study space. It is to witness history itself. During one deep field observation, Webb focused its gaze on a remote galaxy known as JWST 140, one of the earliest galaxies ever observed. Its light comes from a time less than 300 million years after the Big Bang. In cosmic terms, the universe was still an infant. Astronomers expected to find primitive structures, small collections of young stars only beginning to assemble. Instead, Webb revealed something astonishing. The galaxy appeared far too mature. Despite existing so early in cosmic history, it already contained enormous concentrations of matter and intense regions of star formation. Countless stars were igniting almost simultaneously, flooding the surrounding darkness with brilliant radiation. But the greatest surprise was hidden inside the galaxy's light itself. When scientists analyzed its spectrum, they detected oxygen. That discovery changed everything. In the beginning, the universe contained mostly hydrogen and helium, the simplest elements. Heavier elements like oxygen, carbon, and iron are forged deep inside stars and released only after those stars die in violent supernova explosions. For oxygen to exist in such an ancient galaxy, generations of stars must have already lived and died incredibly quickly. The young universe, it seemed, evolved far faster than anyone imagined. Massive stars may have formed almost immediately after the first cosmic structures emerged. They burned intensely, exploded violently, and enriched space with the ingredients needed for future stars, planets, and eventually life itself. In galaxies like JWST 140, astronomers may be witnessing the first great factories of cosmic chemistry, places where the raw ingredients of living worlds were forged near the dawn of time. The implications are profound. If galaxies matured this rapidly, then black holes, stars, and planetary systems may have appeared much earlier than current theories predict. The early universe may not have been calm and gradual. It may have been explosive, chaotic, and astonishingly efficient. After uncovering this blazing relic from the ancient cosmos, Webb shifted its focus closer to home. This time, it observed a dim and mysterious object drifting through interstellar darkness, a brown dwarf. Brown dwarfs occupy a strange middle ground between planets and stars. They are too massive to be planets, yet too small to sustain the nuclear fusion that powers true stars. For years, scientists considered them relatively simple objects. Webb revealed something entirely different. Within the brown dwarf's thick atmosphere, astronomers detected methane, water vapor, and complex chemical compounds swirling through dense clouds of gas. Powerful storms appeared to ripple across its surface. Brightness patterns shifted over time, hinting at violent atmospheric systems unlike anything seen in our solar system. Then came another mystery. High above the dwarf's atmosphere, Webb detected faint glowing structures resembling auroras, luminous displays similar to Earth's northern lights. But these auroras should not have existed. Scientists suspect they may be triggered by the gravitational and magnetic influence of an unseen companion world, perhaps a hidden moon orbiting nearby. If true, the moon itself remains invisible. Yet its presence may already be shaping the dwarf's atmosphere through magnetic interactions alone. An unseen world, revealed only through its influence. It was another reminder that in space, Some of the most important discoveries are not made by directly seeing objects, but by detecting the subtle fingerprints they leave behind. As Webb continued scanning the cosmos, one truth became increasingly clear. The universe is far stranger than humanity once believed. The deeper James Webb looks into the universe, the more chaotic the cosmos appears. Far beyond our solar system, Webb observed a massive exoplanet orbiting its star along an extreme and distorted path. Unlike the nearly circular orbits of Earth and the other planets in our solar system, this world follows a stretched and tilted trajectory through space. Something violent happened there. Astronomers believe the planet's orbit may have been disrupted long ago by powerful gravitational encounters. Perhaps another giant planet passed dangerously close. Perhaps a nearby star disturbed the system. Or perhaps a wandering interstellar object triggered chaos during the system's formation. Whatever the cause, the result is a planetary system unlike our own, unstable, unpredictable, and shaped by cosmic violence. Then Webb witnessed something even more dramatic. A giant gas planet, similar in size to Jupiter, slowly falling toward its parent star. With every orbit, gravity pulls the planet closer. Immense tidal forces stretch and superheat its atmosphere. Over time, the outer layers begin to tear apart, releasing streams of glowing gas into surrounding space. Eventually, the planet will be completely destroyed. Consumed by the very star it once orbited. Scenes like this reveal an uncomfortable truth. Planetary systems are not permanent. Some planets collide with neighboring worlds. Some are ejected into interstellar darkness. And others spiral inward to fiery destruction. The universe is not static. It is restless. Stars are born in violent bursts of energy. Galaxies collide and merge. Black holes consume enormous amounts of matter. Worlds form and disappear across billions of years. Even the earliest galaxies observed by Webb appear more developed than expected. Some may already contain rapidly growing supermassive black holes at their centers, objects so enormous they challenge current theories of cosmic evolution. Instead of unfolding slowly and predictably, the early universe may have experienced explosive periods of rapid growth almost immediately after the Big Bang. Closer to our own region of the Milky Way, Webb has also detected vast disks of icy debris surrounding distant stars. Within these enormous rings of dust and rock, new planets are beginning to form. Tiny particles collide and merge under gravity's influence. Over millions of years, some will grow into massive worlds. Others will shatter apart in catastrophic collisions. These chaotic environments are the birthplaces of future solar systems. And perhaps future life. Every observation made by Webb adds another piece to the cosmic story. Each spectrum contains hidden information encoded in ancient light. When astronomers analyze these signals, they are reading messages written billions of years ago. Messages about creation, destruction, transformation. The deeper Webb looks, the clearer one reality becomes. The cosmos is far more active, far more turbulent, and far more mysterious than humanity once imagined. Yet within that violence lies extraordinary beauty. The same stellar explosions that destroy worlds also forge the elements needed for life. The same galactic collisions that create chaos can trigger the birth of entirely new stars. Even Earth itself exists because ancient stars lived and died long before our Sun was born. The oxygen we breathe, the iron in Earth's core, the carbon within every living cell, all were forged inside stars that vanished billions of years ago. In this way, destruction and creation are not opposites. They are partners in an endless cosmic cycle. And as James Webb continues its silent journey through space, gathering ancient light from the deepest corners of the universe, humanity moves one step closer to understanding where we came from, and what kind of universe we truly inhabit. A universe still unfolding its story.